Welcome to Honors Physics Podcast. This is question number 27 from the Chapter 10 homeworks. We've got a spring hung from the ceiling. A massive block is attached to the free end, and it drops 0.15 meters before it momentarily comes to rest. So if we take a look, our diagrams might look something like this. Initially, we are attached here, and we are headed down. And then at some point in time later, we have moved down by a distance of 0.15 meters. So here, we're looking at energy here. Here we have some potential energy, UG. Because it's the free end of the spring, there's no spring energy there. Over here, though, we have some new potential energy plus some spring potential energy. Some new potential energy plus some spring potential energy. I'm going to just set my zero potential energy line right here, which means that this UG is 0 there. So that means that my UG initially is equal to my US at the end, which means that mg times h initial is going to equal 1/2 k times x final squared. So as we do that, we've got our 4.5 times 9.8. Our initial height is 0.15 meters, and it's going to equal 1/2 our spring constant times our x final. Our x final is negative 0.15. Because remember, and this is why I kept this as x final, because x final is very different than my height. X final is this distance right here. It's the actual distance that is different between them. As you go ahead and solve that, we end up getting that k is equal to 58.8 newtons per meter. As we move forward, part B, omega, that's going to be equal to the square root of k over m. Remember, it has this relationship. Omega is 2 pi times our frequency, and our frequency is 1 over our period, and our period is 2 pi times the square root of m over k. So that's how we get from here to here to here. As we plug in those values, we end up getting the square root of 58.8 divided by 0.450, and we end up with an omega of 11.4 radians per second. Question number 27 from Chapter 10.